multiply x plus 2 times 3x squared minus 2x plus 9. Here we can't FOIL because the second factor is not a binomial. And we could use the distributive property, but it's a bit more complicated when we've got a binomial out front. So in a situation like this, I always recommend what I call the table method. So here we've got 2 terms and 3 terms. So we're going to make a 2 by 3 table for our calculations. The 2 terms of the binomial go on the side, x and 2, and the 3 terms of the trinomial go on top, 3x squared, negative 2x, and 9. You certainly could do it in the other direction, 2 by 3, like I have down here, but just for notes, usually it's better to make it wider than tall. Really, you can do it either way. Once you've got your table set up, to fill in each of the cells, you need to multiply the row by the column that it's in. So this is in the x row and the 3x squared column. So we multiply x times 3x squared, and that gives us 3x cubed. Here we end up with x times negative 2x, which gives us negative 2x squared. And then in this one, we've got x times 9, which gives us 9x. After that, we move down to the 2 row, and we're multiplying each of these by 2. So 3x squared times 2 is 6x squared. Negative 2x times 2 is negative 4x. And 9 times 2 is 18. And then once you have all of the cells filled in, you just need to combine like terms. And more often than not, the like terms end up diagonal from each other. This happens when our polynomials are in standard form. So here we've got 3x cubed, which is the one that goes alone out front. Then when we combine the x squared terms, 6x squared minus 2x squared gives us 4x squared. If you look at the x terms, 9x minus 4x is 5x, and then the constant term there is 18. This is the quickest and probably most organized way to multiply like this. And so I strongly recommend that you get comfortable with the table method when we're looking at larger polynomials with more terms.